From time immemorial, mankind has known about the versatility of lead. In the past, the metal was utilized in many ways, for it is easy to work. Even today, this heavy metal has not lost any of its importance. No car without a battery, and no car battery without lead. But lead is not only indispensable for mobility, the whole modern society is dependent on the reliable storage of energy. Lead accumulators are an absolute must. Electrical engineering cannot do without lead either. For special power and data transmission cables, lead sheathing reliably ensures safe screening and keeps interferences away. Demand for this metal has been on the increase for years. About 1/3 of the lead consumed in Germany originates from BERZELIUS smelter plant in STOLBERG near Aachen. From all over the world, various lead ores arrive at our plant as concentrates, which are converted to high-grade metallic lead by the QSL process. At present, the QSL process is the most advanced and economical technology, and what's more, it ranks top in ecological compatibility. Its environmental harmlessness derives from minimized emissions of sulfur dioxide, dust, and CO2. And it boasts high energetic efficiency because it makes use of sulfur contained in the concentrates to generate the smelting heat. But first, the raw material must be delivered to our plant. In former times, lead ore was directly hauled in the nearby ore mines. Today, the situation is different. The lead ores arrive by ship and by freight train from all over the world. A large roofed-over storage facility was built specifically to ensure environmentally friendly unloading and storage of the ore. The various ore types are transported to the QSL plant by means of belt conveyors. The so-called QSL reactor is at the heart of the plant. A 30-meter-long tube of about 3 meters in diameter. Unimpressive as it may seem from the outside, inside it has a temperature of more than 1200 degrees centigrade. That's hell in the truest sense of the word. In this huge reaction vessel, two basically different processes take place. In the somewhat thicker oxidization zone, lead ore is dropped into a melt from above. At the same time, oxygen under high pressure is injected from below. The sulfur compounds contained in the ore react violently and become ignited. In this 1200 degrees hot environment, the ore is smelted. The liquid collects at the bottom and flows to the outside through the tap on the right side via a siphon. The entire process works in continuous mode and without interruption. All processes taking place inside the reactor are fully monitored and controlled by a means of a sophisticated, state-of-the-art process control system. But if need be, man can interfere in manual control from the outside. Needless to say, the whole inside of the reactor vessel is protected by refractory lining. Through accurate control of the quantitative ratio of sulfide sulfur to oxygen, the lead sulfide oxidization reaction can be controlled at such a high degree of precision that the major part of the raw material can be directly recovered as metallic lead. About 30% is initially retained in the slag as lead oxide. The lead flowing off continuously from the reactor is collected in two vessels that hold 300 tons. One of them is constantly filled with red-hot liquid metal. From the other vessel, the decopperized lead is pumped to casting molds after cooling it to 500 degrees. In the second half of the reactor, a basically different process takes place. In this so-called reduction zone, the substantial amount of lead oxide still contained in the slag is reduced by injecting pulverized coal in a so-called carbothermal reduction process. The metallic lead thus obtained flows back to the oxidization zone. The low lead slag is lighter than lead and floats up until it reaches a level where it can be tapped off. This is done at regular intervals. At the same time, samples are taken there for quality checks and for process control. The slag running off is quenched in a strong water jet and solidifies to form granules that look like grains of sand. These are routed to a slag granulating basin. From there, the granulate is removed by trucks for further utilization. In the process, sulfur dioxide is forming in the oxidization zone. The red-hot off gases are exhausted and, after cooling and cleaning, converted to sulfuric acid in a catalytic reactor. The sulfuric acid produced is a valuable base stock for the chemical industry. About 100,000 tons of sulfuric acid are obtained per year, which are sold to the downstream processing industry. Acid production is steered and controlled by the latest process control systems. As a result, emissions to atmosphere are much lower than in all other conventional processes. Lead production releases an enormous amount of heat. In former processes, it was inevitable that most of the heat input was lost. With the innovative QSL process, however, a large amount of the energy set free can be recovered. The lead bullion produced in the QSL reactor is not a pure product yet, but still contains metallic impurities like copper, silver, gold, or bismuth. In order to remove these impurities, the bullion, weighing tons, is transported to the refining unit, where it is freed from impurities step by step. For this purpose, it is first melted again. Then, stepwise, one impurity after the other is eliminated from the liquid lead. As soon as, for example, the copper is removed from the lead by adding sulfurous agents, the liquid lead is pumped onto the next vessel. Here, the next refining step takes place. Applying the Parks process, silver is removed by adding zinc. The silver-zinc mixed crystals accumulate on the surface. They are lighter than lead and therefore can be skimmed off with a shovel. In the lead smelter, every year up to 300 tons of silver are produced, for example. In a special cupellation furnace, the silver is freed from the residual lead and cast into handy 14-kilo bars. This is auriferous silver, which contains about 1 per mil gold and 0.1 per mil platinum metals. The dross is reprocessed. The byproducts thus obtained are utilized. This ensures that wastage is minimal. The copper-bearing residue, the so-called copper dross, from the refinery and the vessels of the QSL reactor is converted to copper matte in a long rotary furnace. The matte is sold to a copper smelter as feedstock. The lead still contained in the dross is recovered and returned to the refinery. In the plant's own lab, the lead quality and purity are constantly analyzed in the various processing stages. Parts of the samples are vaporized by means of high-voltage sparks. By means of spectrometry, the contents of the respective components are determined accurately on the basis of the light they emit. As soon as all impurities are removed, the lead is of 99.99% purity. It is either left in this condition as high-purity lead, or it is alloyed, according to customer specifications, and pumped as liquid metal to the casting machine, where it is given its final shape. It is cast into 50-kilo bars. When it is cooled on the surface and solidified, the charge number is imprinted on each bar. After further cooling to 70 degrees Celsius, the bars are mechanically extracted from the mold at the discharge end of the casting machine. Depending on customer specifications, the bars receive a color marking, so one can see at a glance, even from a distance, what kind of alloy is involved. Subsequently, the bars are mechanically stacked and weighed. The data are recorded electronically, the stacks marked with numbers, and bundled. Each package stack weighs an impressive 1,250 kilos. Small wonder, therefore, that a truck loaded with 25 tons still looks fairly empty. Year by year, 140,000 tons of lead are delivered to customers. This corresponds to 2.8 million bars. Every customer has individual demands on the material delivered and processes the lead to the respective end product. Car batteries, glass and pigments, semi-finished materials, and cables are the most important applications. And the demand for lead is growing constantly. Good for us and the future of the BERZELIUS smelter plant.